Hello, everyone. So thank you so much for joining Reactor Stockholm today to learn more about Azure Command and Query. We're joined today by Stacy, who is a Tech Explorer DevOps at OmniPlan and a Microsoft MVP in Developer Technologies. So yeah, I'll let Stacy take it from here. Thank you so much.
Hi, good evening, everybody. I'm assuming my computer works. We can get started. Come on, do something. Always the same. In practice runs, it goes perfectly. As soon as you start presenting, it dies on you. Well, good evening, and thank you so much for joining me here today. As developers, we enjoy working on the latest things. We like to keep our skills up to date, and we like to use the best fitting technologies to solve problems in the best way. And over the last few years, cloud solutions have come to fit this description more and more. And yet, sometimes being able to use these technologies takes a lot more effort than we'd like. Some larger, some older companies can still be really hesitant about using the cloud, and whether that's through fear of the cloud or lack of knowledge about the cloud, internal reasons, it still happens that we have many developers who find themselves working on legacy in-house systems. Your code gets deployed, but not as often as you'd like, with a lot more effort than you'd like, and you have no control over how it gets deployed. If you need new hardware, sometimes it can take months before it's available to you. But you've been reading about Azure, the cloud. You've been itching to give it a try. Maybe this is something that you can use to start working in a cloud-first environment. But trying to get that go-ahead is still really difficult. You can find yourselves being asked questions which maybe you don't have the experience to specifically answer right now. Wouldn't it be cool to just quickly build something and try and get those answers and prove what you can do? And at a previous employer, this is exactly the position that we were in. The development team really wanted to move to Azure. The project that we were working on was crying out for a cloud environment. It would have just made our life so much easier. But our ops team and our budgeting team said, absolutely not. Not until you can give us some answers. It's not wholly unfair, of course, but you need to ask the question, what answers are acceptable? Because there's reams of research on this, not least of which the State of DevOps report that supports the move to the cloud in each iteration that comes out. But we're dealing with people, and sometimes reports just aren't good enough. For them, it's a complete unknown, and they need to feel the results and see the results with their own eyes. And so what we decided to do was to have a hack week, give the developers a chance to show what we could build in a short time frame with the whole team working together and see what the costs were at the end of the week. And when I say the whole team, I really mean the whole team. We had all of our development teams, our ops team, and we even got our product owners involved to make sure that the things we were building were kind of useful in the real world and not just tutorial things which had no impact on what we were doing. And I'm going to talk to you tonight and show you about part of the experiment that my team did. Just a simple application that uses a couple of different options in Azure to try and replicate something that we could do to actually help customers. Hi, I'm Stacey Cashmore, and I'm Tech Explorer DevOps at OmniPlan in the Netherlands. I've been programming since the mid-1990s, and I've been playing with the cloud for a few years now, just trying to see how I can use it to help myself and help the company I'm working for, help our users. And like I say, the app that we're going to be building tonight is based partly on that experiment that we did. And it really is just a simplified way to get data from a static Angular site and into Azure storage. To give you some expectations, I'm not going to be covering how I deploy this in detail tonight. I'm using Azure DevOps to do this. I'm going to show you my pipelines, but it's going to be a flying visit in a few seconds. I'm not going to go into depth. I'm also using a pre-made Azure environment for my live demo, because when we create resources in Azure, it can take a few minutes before they're ready, and I'd rather show you working things and how to wire things up than sit there waiting for Azure to do something. But what I am going to do is for every resource that I use, I'm going to show you how to create it so that you see how it's done. And finally, before we start, I'm really sorry. This is going to be a little bit of a pacey demo. I have quite an amount to get through, but don't worry. There's a blog post available where you can run through the demo yourself and see what I'm doing with links to the appropriate documentation on Microsoft Learn, etc. Right, enough talk. Let's get on with the demo. Now, the first thing that I'd like to do is just show you a few of the things that I'm using. I want to start off with the application that you can see now, my book club subscription website. And this is where people can sign up to join a book club. And for that, we need a little bit of information. We need somebody's name, somebody's email address, and the genre that they're interested in. And then we send this off to the server. Now, we're not actually changing this application during the demo. This stays exactly as it is. All the magic happens in the API on the other end. The second one that I want to show you is these pipelines, just very quickly how I'm getting my code into Azure for this demonstration. I have a couple of pipelines that I want to show you. The first is this build API. And all this does, if Azure DevOps keeps up with us, is it has a continuous integration trigger on the branch that I'm using for my demonstration and for a specific path, because I've got a couple of things in my repo that I want to deploy. I've just got 5 tasks that I use to do this. I do a .NET restore, a .NET build, a .NET test for when I add unit tests to this, because of course I want to do that. And then a .NET publish, publishing our project as a web project so that we can easily get it into an app service. And finally, we publish it to the Azure DevOps artifacts so that we can pick it up in our release pipeline. The second pipeline is almost exactly the same. That's something we're going to be using later on in this demonstration. And that is almost identical. We just have a different path we're picking up because it's a different piece of code. And then we have the same restore, build, test, publish, and publish artifact steps. The only difference is we're not publishing a web project, so that's different. So that's how we're building it. We're releasing it using a very simple release flow. So this is the API. We pick up the artifact that we build in our build pipeline, and then I'm deploying it to Azure just using a deploy Azure app service task. And the other one that we're using is a book club signup processor. That is almost exactly the same. We're picking up our artifact. We have one task, and that's deploying an Azure function app. This is a really simplified version of getting your data into Azure, but it's great just for learning how these things fit together. And for those of you who've noticed, yes, this is using the classic way of making pipelines. I've not got around to rebuilding these in YAML yet. But it does make it nice and easy to show you what I'm doing. The application that we're going to be building, we're going to start off with our API that gets the data. And this is almost a web API as it comes out of the box. I've just done a little bit of cleanup. You can't see the weather forecast service or controller here. I've added my model that I use for getting my data from the static Angular site, which again, if my computer catches up with my clicks, you'll see we just have our email, name, and genre. And we're passing that into our currently empty controller. The only other change that I want to show you in this web API, because it is important if you're going to host a static web app, is I did need to add a CORS policy in my startup because the URL for my API is not the URL for my static web app. So otherwise you have issues there. Right, let's get started with the actual demo then. The first thing I want to do here is just show you the simplest possible way to get data from this API and into table storage. So I'm going to do that now just by literally doing it directly here. So I need to create a new folder in my solution or in my project. Let's add this here, and that's going to be called table access, and I'm just using this to organize the classes that I'm going to create. And the first class I'm going to create is called storage table access. Again, if my computer catches up with me, please. Thank you. There we go. And I'm sure that you don't want to spend the next 45 minutes watching me mistyping a load of code. So I've got some code snippets that I'm just going to bring in here and go through with you. So this is kind of the base of the class that I'm going to be building. Now, you can see at the top, I'm using the Microsoft Azure Cosmos table namespace. And you can also see that we have a nice set of red letters there. And that's because this namespace needs a NuGet package before it's available to us. Let's add that now. So we'll just select the NuGet package. We'll install the latest stable version. We're going to accept everything it tells us to accept because, of course, we are. And then we can continue. So this class, it has a connection string to talk to my Azure storage account. Now, this is hard-coded in my class because I'm doing a demonstration. Obviously, you wouldn't do this in production. You get it from a key vault or somewhere safe. And we have a table name. And this table name we're passing in the constructor. And I'm doing this just because you don't want to recreate this for every single class you access. You want to reuse your code. Now, we're only going to be inserting data today. So I'm only going to be looking at how to get data into our Azure table. And to do that, we need a function called insert. This takes a table entity, the particular type of object you need for storing data in a table. And it has 3 steps. The first is getting the table where we want to add our data to. The second step is creating an insert operation for the data that we want to insert based on the entity that we've passed into our class. And finally, we want to execute this insert statement against our table. Now, we still have some red text here, so let's get another code snippet and we'll see how we get a reference to our table in code. So we now have a function which returns a cloud table. And what it does is get access to our storage account using our connection string above. It creates a cloud table client from this storage account. And then we get a reference again to that table name, which we have passed into our constructor. Now, at this point, even if the table doesn't exist, we still get a reference back to it. But if we try to use it in our code, we're going to get errors and it's not going to work very nicely. So we need this next line of code here, which does kind of exactly what it says. It checks to see if a table exists and it creates it if it doesn't exist. And in doing this, we can do code first. We don't need to set all of our tables up in table storage. We can just continue. And finally, the last thing I want to show you in this class is going back to our namespace. You may notice we're using Microsoft Azure Cosmos table. Even though we're talking to table storage, we're using the Cosmos namespace here because the API is the same. So that's how we put things into our table, but how do we actually put our data there? Well, we need an extra class. So let's create that one now. So add a new class. And we're going to call this one sign up entity. And we'll bring in another small snippet here. You can see we're using that Microsoft Azure Cosmos table namespace again. And we are inheriting from table entity because that's what we need in order to store things in our table. Now, when you inherit from table entity, there's 2 fields which are really important. The partition key, how we're going to partition our data, and the row key, what is the key to our data within the partition that we have. You always have to fill these 2 pieces of data, and between them you get a unique key to your record in your table storage. I have wrapped these in properties which are ignored, purely because I don't like having partition key and row key spread around my code. I'd rather keep it something that's at least related to the domain I'm dealing with, rather than being related to the storage that I'm looking at. And the last things we need to add to this class are the fields that we're actually going to store. So our name, our email, and our genre. Just a quick build to make sure I've not broken anything. And that's succeeded, so we can continue. Now that we have our two classes, this is all that we need in order to get data into our storage table. Let's add the code to our controller. So we have two lines of code that I want in my controller. I just need to import the namespaces that I'm using to get access to my classes. The first line gets our table access class, looking at the book club signups table. And the second line calls that insert function with the request that we've got from our user, putting it into the table. But of course, the request is a book club signup request, and this is expecting a signup entity. So we need to do a little bit of adaptation here. So I'm just going to put another function into my class that takes a book club signup request and then just creates a signup entity from it, just copying over our name, email, and genre, and then filling these two special fields, the genre subscription and the unique name, which are taking the place of our partition key and our row key. The genre subscription, I'm just using the genre for. The unique name, because I don't want to get into code to make sure that I don't have clashes in my data, I'm simply taking the ticks from datetime now. I'm appending that to the name of the person that's requested the sign up, just so that every single request I get is always unique. Give that one a quick build. And if this works, we can now push this to Azure and I can show you it running in real life. So let's just add table. Whoops. Get rid of the caps lock. See, this is why you don't want to see me typing code. Add table storage. We're going to commit and push that. And if all goes well, we should see it leave my machine, and then we can check that the pipeline's been kicked off. There it goes. So if we now look at the pipelines, I hope we're going to see the pipeline is now building. So that's the code. While that's building and deploying, I want to show you how to create the resources in Azure that we need in order to host this. So let's go back to Azure. We need to go into our resource groups, and then we need to create a resource group in order to hold our functionality. Now, a resource group, it allows you to group your resources, all of your Azure resources that you need to run your functionality. It makes it easier to maintain it because it's all in one space, you can find it. It also makes the cost overview simpler because you can see the cost for a resource group and not have to add it up for each individual resource. To create it, we just need to give it a name. Let's give it live demo, and we need to give a region. And I'm just outside of Amsterdam, so I'm going to go for West Europe. Now, when I first started using this, I got confused about what the region for the resource group is, and I know a number of other people that also did. This is not a default for everything that we have inside of this resource group. Rather, it's where we store the metadata for the resource group, and that can be important. You may have compliancy things where your metadata has to be in a certain location, so make sure you know that before you start creating things. So let's just review and create that, and we will create it, and we have it. We can go to our resource group. Now, in my intro, I told you it takes time to create resources, and now it looks like I was lying because that was pretty much instant. The resource group is the exception to the rule. I've never had that take more than a second or two. The rest of it takes a little bit more time. So now we have our empty resource group. Let's put something into it. The first thing that I want to add is a web app, the thing that's actually going to host our API. So if we go to the add button in the corner, we can select our web app, and then we can start filling in the details here. Now, because I created this from a resource group, the resource group is already pre-filled here. If you create it from outside of the resource group, you need to make sure you select the right one. You can also create your resource group in here. You can do it all inside one step. We need to give it a name. We'll give it live demo again. And we can see I can't give it live demo. And that's because the name of your web app also determines how it's available to the outside world. And it all runs off of azurewebsites.net. So this has to be unique within Azure. So let's change that ever so slightly. Can we do web app? We can, that's not used. Now we're publishing code. We're running on .NET Core 3.1. We're going to be we're going to be deploying to Windows. I'll explain why later on in the demonstration. And again, we need to enter the region. You can see here, this is back to Central US. So let's make that West Europe again. And now we need to give it an app service plan. Now, if you think of the web app as the IIS that your application runs in, think of the app service plan as the metal that it runs on. So we need to see how we're going to run it. I'm going to create a new one because I don't want an existing one. App live demo app service, that will work. This one doesn't have to be unique to Azure. And then we need to change the SKU and size. How much power do we want our app service to have in order to run our application? Now, I clicked on this change size link down here. I'm sorry if you missed that. And here you see all of the different options that we have, ranging from 62 euros a month up to 833 euros. Depending on the power you have, you can spend a lot of money here. For development and for demos and for practice and for POCs, I like to use this one. It's shared infrastructure, 1 gig of memory, 60 minutes a day, and it's free. Now, the 60 minutes a day can seem a little bit of a misnomer because it isn't that your web app is only available for 60 minutes a day. It only has 60 minutes a day of runtime. So if your web app is busy for 2 minutes per hour with the request that you give it, you're going to use 48 minutes within your day. It makes it perfectly good enough for this type of demonstration, for POCs, for some development, etc. And it's free, which means we can play without spending money. So we have that set up. Let's review and create it. Just quickly make sure I've not done anything odd. I think that's okay. So we'll create that now, and Azure will go and make us our resources. It's going to make us two. It's going to make us an app service, and then it's going to make us a web app inside of that app service. Now, the other thing we need inside of our live demo, you can see here, this is still empty while that's created, is our actual storage account. So let's quickly create that one too. Again, we go back to, let me just go back in. I clicked a little bit quickly there. Live demo. Again, we click on the add button in the corner. We click on the storage account down here. And now we can fill in the details for this. Again, our subscription and our resource group, that's all filled in for us because we came to it from our resource group. We need to give it a name, so live demo. And we can't because the storage account name has to be lowercase letters and numbers, which can make for really awful names that are hard to read because you can't do kebab case, you can't do camel case, Pascal case. It's unfortunate. So we can also see it also has to be unique within Azure. So you've got to think of a name which is difficult to read, which nobody else has used. So you need to come up with a good strategy for this. We're just going to call it live demo storage ACC, and that works, thankfully. The location again, and as with everything else, I'm going to West Europe. The location has two important factors relating to it. The first one is latency. This is where our web app is going to be pushing data to, and in the future, reading data from. If you host this in the same region as your web app, you're going to have latency in the milliseconds. If you host it on the other side of the world, you're going to have latency in the tenths of a second or so. This is going to make your users really unhappy. Don't do that. Keep it next to the metal. The other one is, again, with our metadata for our resource group, compliancy. You may have rules within your region about where you can store personal data from your users. So make sure that you set the location for this in a place where it's legal to store the data that you're trying to store, and make sure you put your metal next to your storage. Performance, I'm not going to go too in depth with this. We have standard, slower, we have premium, faster, more expensive. We're going to pick standard here, and the type of account that we want. We have 3 options: blob storage, tailored for blobs; storage general purpose V1, which is for legacy use only. If you're writing a new application, don't pick this one. And a storage V2, which gives us access to blobs, files, queues, and tables. So this is the one we're going to be using. Next, we look at the type of replication we have. And storage accounts always have replication. Your data is redundant even on the cheapest layer. What you pay money for is where your data is redundant. So if we start with the lowest, the locally redundant storage, that is redundant within the same data center as your primary data. If something happens with the equipment, you're covered. If something happens with access to the data center, you're not. You don't have access anymore. If that isn't acceptable for you, you can move up to zone redundant storage. Here you store your data not in the same data center, but once in one data center, once in another, within the same region. If one data center becomes incapacitated, you can still access your data. If something happens in a region's not available, which we've seen, obviously you lose your data or you lose access to your data. If that's unacceptable, then you can move up to geo-redundant storage. Now we store the second copy of our data in a different region. If something happens to the region that we're in, we get a failover to the second region. This takes time. And if your data, or if it's very important that you don't have a disruption of a few minutes in accessing your data, then you might want to go up to the next step, which is read access geo-redundant storage. Not only are they more expensive the further down you go, they're more difficult to say. The read access geo-redundant storage is exactly what it says on the tin. We can access our data anytime. So you can set up your own heartbeat. You can put the data close to a second set of users and they get access to it easier. But other than that, it's pretty much the same as a geo-redundant. Then we have 2 new ones that appeared this year. Earlier on this year, I think they were preview. Now they're general availability. The geo zone redundant storage, which kind of combines the zone redundant and the geo redundant. And the most difficult to say, the read access geo zone redundant storage. That gets easier every time I run through this. And that's pretty much the same as the read access geo redundant storage data. Your data is duplicated across zones and across regions, but you can read access the data at any time. After all of that, we're going to pick locally redundant storage because I want the cheapest option for the demo. Next, we have the blob access tier, and I'm going to skip this because we're not using blobs in this demonstration. So we're just going to leave that to hot. So let's review and create this. Make sure I've not done anything strange again. And while that's creating, let's go and take a look at our pipelines and see if we can actually see something working in the real world. The build API built 11 minutes ago. The pipeline ran about 10 minutes ago. Now I can show you this working. There's one more thing that I want to do first, though. I just want to show you my current storage in my running demo group. This is my pre-made resource group. Inside our storage account within our resource group, we have this option here, Storage Explorer. It used to be that in order to view what's inside your storage account, you had to install the Storage Explorer locally. We no longer have to do that. We can do it in the browser for quick access. It can be useful to have it locally still, but for a quick check, this is great. It is in preview. It does have some quirks sometimes, but it works pretty much okay. And what I want to show you is I have no queues and I have no tables. That becomes important in a second. So let's sign somebody up to our book club subscription. And the person I want to sign up is Amy Pond. And Amy is on the TARDIS. And the genre that she's really interested in is 40s crime noir. So let's send that in. Now, if we come back to here and refresh the Storage Explorer, if all has gone well and I've not made a daft mistake, And I have made a daft mistake. Why isn't that working? Okay, that's interesting. Don't you love it when these things happen? We deployed that. Sorry about this. We built it. This never happens when you're doing a run through. We've added our table storage. We have our commit. And our commit has everything we need. That's interesting. Ah, okay, sorry about this. It appears my connection's possibly doing interesting things. Let's try that one again. Amy Pond, Amy at the TARDIS, and Fortis Crime Noir. And that's still dying on me. Why is cause broken? I'm sorry about this. I'm just looking at this right now, just so that you can see what I'm looking at. It's been blocked by cause policy, and yet it shouldn't have been. Something's changed since this afternoon. I'm going to look at this just for 2 more minutes, and otherwise I'm going to run the front end locally and get it working that way. It means I can't show you the demonstration in Azure, but you'll see what it does. Nope, I don't know why that one is working. Okay, I apologize for this. Give me 2 seconds. I'm just going to go to my backup plan of running this locally. Where are we? Can we open? No, that's not the right one. Oh, isn't life fun when these things happen during a live demonstration? Come on, do something, computer. Right. Just show you what I'm doing here. Otherwise, you're just staring at your screen thinking, what's she doing? CD Azure. And I want the front end. And I want to open code here. So we have our URL. I am really sorry about this. This isn't something that's come up in any run through yet for this. And I want to run that to localhost. That's good. And we want, come on, be quicker. ng serve. Right, I'm just trying to fire up a localhost version of this. But my computer is now also really playing up with me. Because of course it is. Okay, come on, do something. Right, this is building up. Let me show you this so that you can see what I'm looking at too. Right, so I am really sorry. I don't know why my computer suddenly decided to die on me. What are you doing? Okay, what other options do we have here to move forward? I'm going to give this just a couple more minutes, and if it doesn't work, I'm going to go through the coding with you, and honestly, it does work. That's assuming my machine does something. My machine is completely frozen up here. I am really so sorry. Come on. No, okay, I'm really sorry. I'm not going to actually be able to show you it working. I'm going to go on. It might come back later, but for now, I'm going to just carry on with the coding demonstration. It's not as interesting. I'm sorry. So if this had have worked, what we would have had is a synchronous application where a user could sign up to a book club. We would take that data into our web API and put it straight into a table. It's simple, but it has some issues. The first one is scalability. If Amy signs up to our book club, she's really popular. So everybody's going to want to join our book club and they're all going to pile on. And scaling out the web app to do all of the work we need to do is expensive and more difficult than doing something further down the chain. The other one is we're going to do more than just put our data in a table. We're going to be checking the address that we've been given. We are going to be processing it. We're going to be creating user accounts, all sorts of stuff. And all of that can go wrong. We don't want it to go, well, we don't want our users to see when it goes wrong. We want to catch that and deal with it ourselves. So what we're going to do now is change this from being a synchronous connection to an asynchronous connection. We're going to stop talking to the table access and we're going to start talking to an Azure queue and then pick it up later on. So the first thing that I want to do is add a new folder again. If my computer does anything, I really don't know why it's doing this to me today. Come on, do something. It's for some reason my CPU is going absolutely mad right now. Come on. Let me rename this. Right. You know what? We're just going to add another one. And it still won't let me rename. I'm running it. Of course I'm running it. Sorry, that's my fault. That's panic creeping in. Don't panic. It doesn't help. So we have our queue helper, and our queue helper is going to have a class which is called queue access. And again, I have code snippets here to try and stop bad things from happening. I think we can all agree that that's not going to happen anymore. So this uses the Azure Storage Queues namespace. And you can see we have red letters there again because it's a different NuGet package. So let's go and add that one now. Manage your NuGet packages. Let's go and install it. And we're going to install the latest stable version here. And that's really important that we do pick the latest one, which I'll come to in just a couple of seconds. We'll accept everything again, and then we'll go back to our class. Now, this looks fairly similar to our table access class. We have a connection string, which you're not going to keep here in production. We have a queue name, which we pass into the constructor. But then we have to do something different. We're now going to write our task. So let's add that here. And here you can see we're adding an object, and that's just a plain old system.object, which is our message. We don't need a queue entity or something here. We are going to get a queue client. We are going to encode our message as base64 JSON, and we are going to send this to our queue client asynchronously. How do we get our queue client? Well, we try and get something onto our clipboard. So in order to get our queue client, we first get a queue service client from our connection string. We then get a queue client for our specific queue using that queue name we passed in the constructor. And again, this doesn't have to exist at this time. We have this second call again, create if not exist async. And the reason why we needed to install the latest version of the Azure storage queues is because otherwise this doesn't exist. This only came in the March release, 12.3, I believe. Before that, the first time I gave this talk, I had to write this manually. That's bad. If Microsoft can write it, that's fantastic. It's one less thing I have to worry about. And the final one that we need to do is add this to base 64. In a previous legacy API, the Microsoft.azure.storage.queue namespace, when you sent a message to the queue, by default, it was base 64 encoded. In fact, you had to turn it off if you didn't want that. For the new namespace, you have to do it manually, unfortunately. So we'll just add this one down here. And it's important that we do that because if you don't base 64 encode your message, when you try and read it in a function, it's going to crash on you. So let's go back to our controller now, because this is all we need for accessing the queue. And we can do a little bit of cleanup. Come on, do something. So we can replace these two lines with one line. If we import our using statement, we get a new queue access for our queue, which is book club signups, all lowercase. You can't do kebab case, camera case, Pascal case. You can only use lower letters and numbers. And we're going to add our request. No adaptions needed here. It's a plain old C# object. So let's get rid of this adaption down there. This is now all we would need to do in order to send things to our queues from our front end. So change table for queue. I'm going to send this up to Azure. I know it's not working, but it's just muscle memory for me. Right. Is this? Hey, look at this. My Angular server is now working. Does this mean that I can actually talk to localhost? No, it doesn't, because I stopped my server. No, I'm not going to try that. I'm sorry. I'm running out of time and I want to show you the functions first. Assuming this actually worked, we would now have our message waiting in the queue, and we now need to do that asynchronous processing. For that, we're going to use an Azure function. So let's create that one now. If I can find what I want to do, because I need to give it a name. So let's make a new project. And again, at some point, this is going to start working for me. And we're going to make an Azure function. You can search for it in the template, but the way my machine's coping, I'm not going to try and risk that for you. So we need to give it a name. It's going to be book club signup processor. And again, muscle memory, just because I know it should go in a certain location for this demo, I'm going to put it there anyway. So we're going to create this. Now, when you create an Azure function, you can have lots of different types of trigger. You can have a completely empty one where you have to do everything yourself. You can have scaffolded blob triggers, Cosmos DB triggers, HTTP triggers. So I didn't actually need the web API in order to run the front end, but there's a reason why I chose that. I'll come to that when I come to create the function in the Azure portal. But we want a queue trigger. And for that, we are going to wire it up to some storage. And again, I'm going to pretend that everything is working, and I'm going to pick my live demo storage. We have a connection string. This is something that you would use to wire up lots of different storages if you need it inside of different functions. I'm not going to use this right now. I just used the default wired up storage account, which is associated with the function. It just makes life a little bit easier when you're just playing around and doing a demo. And we would need the queue name, which should have been book club signups. So let's create our function. Please create our function at some point. Wow, my machine is not happy. Honestly, this does work. This is standard Visual Studio stuff. Wowzer. There we go. We eventually got there. Now, I want to do a little bit of cleanup on my book club, on my function, because I don't like the default stuff out of the box. But apparently I'm not allowed to. Thank you. Now, the first thing I'm going to do is change the name of the function. Am I really? And we're going to call that our book club sign up function because that makes more sense to us. Yes, change my class name too. Please. Pretty please. We're also going to change this attribute here. And this attribute, this function name, this is how it appears inside the Azure portal. This is really important that you don't put a space in here, because when I was first looking at it, I did put a space in here and it builds, it deploys. And then I spent an hour trying to figure out why A wasn't working and B, I couldn't see it in the portal. And it's because this can't have spaces in it. If you put a space in, it doesn't work. You get no warnings. You pull your hair out. Don't be me. Don't do that. I need to clear out this connection string. This is that empty connection string in the create that we didn't use. And then we have our base function. If we ran this now, we would put a breakpoint on this log line. What we would see when we get the queue item is a JSON representation of that message. All you need to do then is deserialize it back into an object and use it. But you don't actually need to deserialize it yourself. You can actually get Azure to do this, the function to do this for you. Now, since I've wasted enough time trying to do stuff, I'm not going to try typing out any more code. I am going to copy the things we need from our signup API and just drop it straight in. Now we have our table access and our book club signups. Let's just fix the namespaces, because obviously this namespace is still from the signup API. It needs to be for this solution. Thank you. And we have our storage table access class. Now I'm running out of time, so I'm not going to go through the whole Nugget package thing for this, because I'm not going to be able to demonstrate it, unfortunately. I just want to show you how we would use it. And it's pretty much exactly the same as we did in our API. We just have the same 2 lines of code. We'll import our usings again, and we also need that adapt function, of course. So let's copy that one across. We'll import the namespaces again. That should now work. Now we still have some red lines here, and that's because the function is slightly different to the web API. For one thing, it's a static class. So we need to make this function static. Another is this is asynchronous, and the scaffolding makes a synchronous function. So we just need to make this asynchronous. And finally, we need to change this to request so we can use it. In theory, this is all we need to do. If we now built this and deployed it, it would take some time, but we would have it ready and able to use. I'm not going to bother committing this and pushing it in. What I am going to do is show you how to create a function and the options that we have within the Azure portal. So let's go back to our resource group and our live demo. You can see here that we have those resources that we created earlier on, our app service, our storage, our web app, and our application insights, because I didn't turn that off. We come back up to the add button again. and then wait, and then wait some more. Yep, we can now create our function app. And then we wait again. I am really so sorry about this. I've never had it this bad before when I've been running through my demos. So we need to give the function app a name. So let's call it live, because I just want to show you again, this runs under Azure Websites Net. This has to be unique within Azure. So not live function app. Is that okay? That's okay. We're going to be publishing code. We're going to be publishing .NET Core 3.1. And again, we want it running in West Europe, the same as everything else. We're going to have a look at our hosting. Here's where we say how our function app is going to be kept in the air. Now, first of all, we need a storage account for this. I'm going to create the one that we just made, the live demo storage account. When you make a function, it doesn't actually run permanently. It only runs when it's used. In the times when it's torn down, when it's not being used, your code has to live somewhere, and that's what this storage account is for. This storage account has to live in the same region as your function. Again, for latency reasons, you want to copy that data over as quick as possible. So if you create this in central US, I wouldn't have been able to pick the storage account. I'd have had to have picked a different one. Then the operating system, we're going to be using Windows. And we're going to be using Windows because we're going to be running this as a consumption serverless function. And the reason why we need Windows is there's a limitation with app service plans, consumption app service plans, specifically for Linux. If you use one, that can be the only app service plan in your resource group. You can get around this by using 2 resource groups, one for your function, one for everything else. But for the sake of the demo, I just wanted everything in one place, and that means using Windows. This is all we need to do for creating the function app. We then just do the review and create, and that's it. In a few clicks, we have all of the resources that we need. Obviously, in real life, you're going to be doing this with your infrastructure as code in your pipelines, but it's good to know how these things actually happen. Now, unfortunately, I'm supposed to end up with a last final fantastic demonstration of showing you that Amy's husband can now join the book club using the cues, going to the table, and everything's fine. I can't do that, so let's get back to our presentation. So one of the questions we wanted to answer when we did this at my previous employer was, how much are we going to be spending if we move to the cloud? Our budgeting team were seeing hundreds of thousands of euros floating before their eyes, and that was something that scared them. So in writing this talk, we're doing lots of practice, lots of dry runs when I've never had this issue as I've had this evening, making lots of mistakes. I spent a total of €6 spent. I actually spent these days about 9 cents because I've been running this a couple of months more since writing this slide. But by using the Azure cost calculator, I managed to figure out how I could make this run really cheap. But this is just for a simple demo. What about for the bigger group? Well, in our hack week, with a department of 6 teams, 35 developers, using lots of different options, not just functions and storage accounts and app services, but machine learning, Azure Signal R, logic apps, lots of stuff. We spent in total €25 for the 2 weeks that we were setting up and running our hack week. Yes, in the cloud, you do have to be careful. If you pick the wrong option, you can spend lots of money and you know about it when you get that very big bill. So be careful. But if you're careful, or if you are careful, you can create an awful lot of value without spending an awful lot of money. I invite you to play, experiment, try things out. See if you can get it working better than I did this evening. If you're lucky enough to have an Azure, if you're lucky enough to have a Visual Studio subscription, then you get Azure credit, somewhere between 45 and €130 per month, every month of your subscription, if it's yearly. Use this. Even if you do something wrong and create those expensive things inside of these subscriptions, and I've done this, The only thing that happens is you use up all your credit and you can't do anything until the next month. You don't actually spend anything above your credit limit. If you don't have that luxury, then you can always take your own private Azure subscription. It's actually how I'm running this demonstration. You get 12 months of selected services for free and 170 euros of credit in your first month. This is obviously a more risky approach because if you do something odd, you're not using credit that disappears, your credit card is going to be hit. So please, please, please use that as your cost calculator and have an idea before you start randomly clicking create buttons. That is it for the demonstration. I am really sorry I couldn't get you to see it working, but please have a go. Try and create something simple in Azure yourselves, have a play, see what you can build, and watch it work better than this did. As I say, there's 2 links on the screen right now. I'm going to put them on Twitter later as well. One of them takes you to Microsoft Learn for adding a storage account to an application. And the other one is a blog post which goes through the steps I did here to create an environment locally on your machine, doing everything that you need to do in order to talk to a storage account. There's a second one coming in a week or so that actually puts it into the Azure environment itself, so you can see it in the real world. Thank you for your time, and I hope you were less stressed than I am. Have a good evening.